Okay, hello, honors pre-calculus. Um, I am out for seventh hour or eighth hour today, so I recorded a video. It will most likely be in two parts because, as you know, I can only record for 15 minutes at a time. But I will try to go as fast as I can, and then if it's too fast, you can always pause it. Um, so this is the last section of chapter 8, and it's actually 8.6. Old book, it used to be 8.7. Um, oh, and I should just tell you before I forget that since we are off a day, tonight's homework is in the book. Monday will be the 8.6 worksheet. Tuesday will be the review, and then Wednesday will be the test. Okay, so anyway, this is more probability. So uh, this first page is stuff that I think most of you are comfortable with already. We've already talked about sample space and how that is just all of your possible outcomes, and how sometimes it's a good idea to write them all out so that you can visually see how many there are. And then if you're trying to find a specific probability, you could literally circle the ones that apply. That might be helpful. Um, this is the general formula right here for finding a probability. It's a fraction, and it's what you want to find on top out of the total possible on the bottom. And this is saying right here that your probability is going to be between 0 and 1. Think of it as percent. This would be 100%, and 0 would never happen. 0 will never occur. 1 is a sure thing. So let's just write out the sample space. If we were to flip a coin one time, we could either get a head or a tail. If we were tossing two coins, I could get two heads, I could get two tails, I could get a head and then a tail, or a tail and then a head. Those are all my options. Three coins, I could get all three heads or all three tails. I could do heads, heads, tails, or tails, tails, heads, heads, tails, heads, tails, heads, tails, or heads, tails, 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 heads, heads. So when you're doing a problem, and if it describes a coin being tossed 3 times, this would be your sample space. So the bottom of your probability would be 8, and then we would try to maybe circle the ones that would apply. And I think I have an example of this on the next page. Okay, so our first example is 2 fair coins are tossed. What's the probability of getting exactly 2 heads? So remember, our sample space, if you wanted to write it out, was heads, heads, tails, tails, heads, tails, or tails, heads. So what's the probability of getting exactly 2? Well, this is the only one that's exactly 2, and that happens 1 out of 4 times. And for notation wise, we would say something like this: the probability of x equaling 2 heads would equal 1 out of 4. Let's say 3 coins are tossed. What's the probability of getting exactly 2 heads in that situation? So let's write out all those possibilities again from the last page. Well, you wouldn't have to write them out again because you already have them written, but I will write them out again. Let's see, what was the other one? Okay, I think I got them all. So what's the probability of exactly 2? That means not less than 2 or more than 2, just 2. So here's just 2 heads, here's just 2 heads, and here's just 2 heads. So that would happen 3 out of the 8. So this is saying the probability of getting exactly 2 would be 3 out of 8. This one did not get circled because that's more than 2. This is exactly 2. Okay. What's the probability of drawing an ace out of a standard deck of cards? Here's some information you might want to know about cards. I feel like teenagers don't play cards quite as much as they used to, so you might not be aware of some things. There's 52 cards in a deck. There's 4 suits: spades, hearts, diamonds, clubs, and each suit has 13 cards. The cards go ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 cards of each suit. Face cards literally have a face on them: jacks, queens, and kings. Okay, so anyway, going back up here, what's the probability of drawing an ace? Well, how many aces are there? There's the ace of spades, there's the ace of hearts, the ace of diamonds, or the ace of clubs. There's 4 aces out of the total deck. So the probability of getting an ace is 4 out of the 52 total cards. And if you want to reduce that down, you can to 1 over 13, which you can kind of see here. There's 1 ace out of every 13 cards in each suit. Okay, the next concept is knowing when to multiply 2 probabilities together and when to add 2 probabilities together. That's a huge source of error for kids, is mixing up when to multiply and when to add. So we'll start up here. If the events are independent, then you're going to multiply. In order for them to be independent, we've kind of talked about this already. If one happens, it has no effect on the other one happening. Like, the probability of one happening does not change the probability of the other happening. They could happen at the same time, but the probability of one will not affect the probability of the other. Wording wise, you're going to see the word and a lot. So if you see and, then multiply the 2 different probabilities together. So here's an example. What's the probability of drawing a jack of hearts? Okay, well, just think about how many jack of hearts are there in a deck. Well, there's only 1 jack of hearts in the entire deck. So we're going to expect that our answer is going to be 1 out of 52. But I want to walk through why this formula works. A jack of hearts is both a jack and a heart. So if I wrote this out, it would be the probability of jack and heart. So theoretically, I could take the probability of drawing a jack and multiply it by the probability of drawing a heart. So the probability of drawing a jack, how many jacks are there in a deck? There's 4 jacks out of 52. How many hearts are there? You know, if you want to go back a page, how many hearts are there? There's 13 of each suit, so there's 13 hearts out of 52. And if you multiply 4 out of 52 times 13 out of 52, you get 1 out of 52, which is totally what we expected because we already knew there was only 1 jack of hearts. But I just wanted to show you why the formula worked. Okay, if you see the word or, that's going to be your signal to add rather than multiply. The thing that you have to be careful of is if you have an or, you're going to do A or B, let's say. You're going to find the probability of A plus the probability of B minus this. Okay, what's this symbol? This symbol is the symbol for and. So what that means is, well, let me show you in a little diagram, okay? Let's say this is A and this is B. A and B would be this overlap. That's A and B. So if I want the probability of A or B, maybe colors would help. Here's the probability of A. That whole circle, including where they overlap. That's the probability of A plus the probability of B. That would be this whole circle where they overlap as well. Okay, but do you see how I counted that overlap twice? That overlap got counted once in the red and again in the green. And I counted that space right there twice. That's why I have to subtract it off, because I counted it too many times. Okay, so this is the overlap. Now, depending on the problem, there might not be an overlap. That you might not be able to have both events happening at the same time. You'll see in a couple examples about that. But let's try this one right here. What's the probability of drawing a jack or a heart? So probability of a jack or a heart. Okay, so if we follow the formula, that would be the probability of a jack plus the probability of a heart. And then we have to subtract any overlap. That would be the probability of being a jack and a heart. Okay, so the probability of drawing a jack, which we already discussed, is 4 out of 52. The probability of drawing a heart, we already discussed, is 13 out of 52. And we have to subtract off how many jack and hearts there are. That's the jack of hearts, which we already found right here. There's only 1 out of 52 cards that are both a jack and a heart. So put that all in and we get 4 over 13. Okay. Pretty soon I'm going to have to stop this video and then start the second the second video. I don't know what I'm trying to say. But really quickly, I think one last thing. I forgot about this. The symbols, okay? If you see or, this is also the symbol for or. So or has kind of a U. That stands for union. And has that for the symbol. So here's how I think of it. I think of it kind of like a curvy A for and, but it doesn't have the horizontal bar through it. So I don't know, that's just how I think of it. It looks kind of like an A. Okay, one last concept and then we'll start the next video. Mutually exclusive means the two events cannot happen at the same time. Mutually exclusive means they cannot happen at the same time. So like Jack and 8. I cannot draw both a Jack and an 8 at the same time. Those would be mutually exclusive. If they are mutually exclusive and you want to find or, then there would be no overlap. Mutually exclusive would look like this. That would be like the jacks, this would be the 8s. They never overlap. That's mutually exclusive. So that's why we don't need to subtract anything off of here. This is the same formula, right?